Welcome back, and today we're going to take a look at density. And density is essentially how dense a material is, and that's going to be how massive it is in a given volume. Something that is really has a high density is going to be very heavy, have a lot of mass, but in a smaller volume. Something that is not very dense is going to not have a very large mass, but occupy a much larger volume. All right, we've got a couple examples here, and this is going to be some atom. And up here, let's say that it's in the liquid phase compared to down here, which we'll say is in the solid phase. And what you need to look at is if these are the same number of atoms, the mass would be the same. However, the volume up here is going to be greater, which is going to make this less dense. The volume's in the denominator. The bigger the denominator is, the smaller the density is going to be. Compare that to over here, and now we've got, this is going to be a cup of mercury, and we've got this pool ball sitting on top of it. Notice how little, there's just a tiny part of that ball even gets submerged, and that's because the density of the mercury is so much greater than the density of the pool ball. So we're going to define density as equal to the mass over the volume. Now, some common units for density will be grams per milliliter or grams per centimeter cubed. Coincidentally, a centimeter cubed equals 1 milliliter. So those would actually be equivalent. So we've got our equation for density, and let's take a look at another couple pictures here, and then we'll do some problems. All right, over here on the left, we have water that is in that's in the liquid phase. Compare that to water that's in the solid phase. You've got the more rigid crystalline structure. And notice what happens to the volume, the space that the water occupies when it's in the solid phase compared to in the liquid phase. And you can see that it occupies more volume, making the solid form of ice, or the solid form of water, less dense than the liquid. And that's why the ice will float. All right, now we've got this problem here. We're going to look at the density of mercury is 13.6 grams per milliliter. And the question is, what is the mass of 8.2 milliliters of mercury? Okay, now you can, if you feel more comfortable, use the equation, or you can come over here and let's treat the density as a conversion factor and write down what we're given. And we're given that we have 8.20 milliliters of mercury, and I want to find out the grams. So I'm going to use the density as a conversion factor. So I'm going to put the 13.6 grams in the numerator, and that's in 1 milliliter. And look at what happens to the milliliters. They cancel out. Let's throw this in our calculator, and I essentially get 111.5, and that would be grams of mercury. Now, significant figures are going to play a role this whole year, so we've got to go back and check and see how we're doing. And do you see how we've got 3 significant figures? This 0 counts because it's telling us it means something. It's to the right of a non-zero, to the right of the decimal. And I've got 3 significant figures here. So in order to make this answer correct, we need to really come over here and make this 112 grams of mercury. All right, now let's do part B, and on part B, let's write down what we're given. We have 120 grams of mercury, and this time I want to find out the volume. What will be the volume? Again, I'm going to use my density as a conversion factor, so I'm going to put 1 milliliter in the numerator and 13.6 grams in the denominator. We want to have labels for everything. Look at what happens to the grams of mercury. Whoops, I should have a gram of mercury there. So we take 120 divided by 13.6, and I get 8.8 milliliters of mercury. Now, I made my answer 2 significant figures, and the reason I did that is while the density is 3, this 0 is just a placeholder. It's simply telling me how big the number is. So we've calculated those 2. Let's try another one. Okay, now this is going to be more in line with if you were doing an experiment. And so we have a student pipette's 5 milliliters of ethanol into a flask weighing 15.25 grams. Okay, so we've got this nifty little flask here. Yeah, I'm going to do some nice drawing here. Whoops. Okay, and so I know the mass of my flask is 15.25 grams. But then we're going to go ahead and we're going to fill it up with a little bit of ethanol. So I'm going to add a little bit of ethanol in here. And now all of a sudden the mass of the flask and the ethanol goes up to 19.17. How come? Why is there a difference in mass? Well, it's due to the fact that the difference between these is the mass of the ethanol, which is actually what we need, because in order to find the density, I need the mass and I need the volume. So the mass of the ethanol then is going to be the 19.17 grams minus the 15.25 grams. Now we're doing significant figures where it's the place that matters and not how many significant figures you have. And when I subtract that, I get 3.92 grams of ethanol. I'm sorry, I don't know if you heard my dog snort, but all right, so we've got our mass, and now we want to find the density, and density is going to be the mass, which is 3.92 grams divided by the volume, and the volume is the 5.00 milliliters. All right, how many significant figures do we have here? 3, and we have 3 here. These are not placeholders, they count. And we divide them, and I get 0.784. And the reason I'm giving 3 significant figures is because we've got 3. So we have 3.784 grams per milliliter. And there you go. See you next time.